Hello everyone. This is a video lecture for Calculus 2, section 10.3 and 10.4, polar coordinates. And so I combined these in my notes because they were very short and easy. We're going from rectangular to polar, and that's actually pretty easy. We've been doing this here since pre-calculus, even some of this in college algebra. I'm not worried about this one at all. So let me just give you these basic formulas here that you've seen before. There you go. X equals r cosine theta, y equals r sine theta, r squared is equal to x squared plus y squared, and tangent of theta is equal to y over x. These four equations are so super important that you should memorize them for sure. I'm not a memorizing kind of guy, but these are memorizable. So let's just do some pre-calculus. Yay! Honestly, that's all this stuff is right now. So r theta is equal to, we have 3 pi over 2, and they want to go to rectangular mode. And so this is my r, this is my theta, so x is equal to r cosine of theta. Cosine at 270 degrees is a 0, and so we get a 0. Y is r sine theta, and so this guy right here is going to be a -1. 4 times -1 is a -4, and so your answer here is very simply this guy here, and that's how you type it into WebAssign. And then you just repeat. I have a little repeat note here because apparently there's more than just this one on this particular question. But it's very simple. 10, 3, 0, 0, 5. So I've got my xy point is equal to 4 square root of 3, and they say find r and theta. Well, my r is going to be the square root of 4 squared plus 4 square root of 3 all squared. This yields a 16 plus 16 times 3, so that's actually going to be a 16 times 4, which is, well, it's going to end up being an 8 is the answer, so there you go. One thing about this, though, I just quickly said r equals the square root. Well, technically it's a plus or minus all the way through, and so we're going to have a plus or minus 8. Keep that in mind as we keep going. My theta is going to be gotten from my tangent theta is equal to y over x. The 4's cancel. And if you remember, maybe you remember, tangent theta is equal to square root 3, find your answer. You might just know the answer. Instead, what I always do is I say, well, I know there's divide by 2's everywhere. So that's technically this guy. Created the 2's out of nothing. My y value is bigger. My x value is smaller. So it's going to be here at 60 degrees. And technically, that's it. Another way to understand is down here, because your tangent could be both negative, so you could have a negative and a negative, and it would be down here as well, at not just 60, but the 240 degrees. So there's two answers there as well. Now we have to put it all together, and so the two different answers that they have, I'm going to show it to you and understand why we have it. 8 pi over 3. -8, 4 pi over 3. That's their two answers. That's what they have. So why only those two? Why not 4? Like you got 1, 2, 3, 4 combinations. Well, my original point here is positive, positive. It is only here in quadrant 1. This is my result. It's right there. And so I could go 60 degrees and positively. The alternative is that I can go basically facing this 4 pi over 3 direction, but I walk backwards. I don't know what I just did there. I walk backwards to get my answer. Walk backwards. In class, I often like to show this where I'm facing this way and I walk positive. But then I'm facing this way and I walk backwards. And I end up being at the same location. The idea is that you can alter and change those to be able to get to that same point. I'm sure there's other answers, but those are the only ones between 0 and 2 pi. So, okay. Now to something a little bit more interesting. We have r is equal to 7 cosine theta, and they're saying convert this over into rectangular form. So we're trying to make this into rectangular format. And it's pretty easy to do this, but I want to just remind us, what's that graph right there? Well, it's a circle on the x-axis out until 7. And so that's what your answer is. Your goal in rectangular form here is then going to be a circle format. It's going to be x squared plus y squared equals r squared, something kind of like that. Of course, it's going to be a little different because it's been shifted over 3.5 along your x-axis. So how do we actually get this rectangular format without just knowing that stuff? What I actually do here is I leave the r alone for just a second, and my cosine is x over r. Do you remember that one as well? I can take this r and move to the other side, so r squared is equal to 7x. And r squared is actually x squared plus y squared, which we saw earlier. And that's your answer. What you could do if you wanted to get it into a real awesome circle format, you would have to find out where it's being shifted and then find its radius. To do that, you would need to complete the square. So you'd have the x squared plus 7x plus something minus something, blah, blah, blah. Complete the square. Okay. I'm not going to do it. This should be good enough. Okay. I got 10, 3, 0, 1, 9. I got r squared times cosine of 2 theta is equal to 36. And what they want is to convert this into rectangular form as well. We have to do a little bit of math in order for it to work. This cosine of 2 theta, actually there's a formula for that. It's 2 cosine squared theta and then minus the 1 equals 36. And I know that this is going to be an x squared over r squared, because that's my cosine there. When I distribute, that's multiply, so I distribute to both of these guys right here and here. What I actually get is 2x squared r squared over r squared, and then I got an r squared, 36. These guys cancel, of course, so 2x squared minus r squared is equal to 36. This finally converts down to x squared minus y plus y squared. Distribute your minus sign. And so this actually right here actually is a 1. 2 minus 1 is going to be a 1. X squared minus y squared is equal to 36. Now what's the shape of this guy? He's actually going to be a hyperbola with an x major. It's positive right there. So there you go. Pretty cool stuff. I hope that you're seeing a particular format. We could automatically change all of my r's like immediately into the square root of x squared plus y squared, but it looks so clunky. I don't like doing any of that. I do that often whenever I just kind of don't think about it, but when I'm actually like sitting down and saying, hey, I want to make this look good, I just leave the r's alone until the very end, okay? So it's just a technique. Again, if you like a lot of x's and y's flying around with square roots, it will work. It's just not pretty. Okay, 10, 3, 0, 3, 6. So I have an r is equal to 2 plus 5 cosine of theta, and they say graph this thing. If you remember, of course you remember, if you remember all of your shapes back from pre-calculus conic stuff, then this will be easy, right? Yeah, I don't remember them either, so no clue. So there's two options. You could do the Desmos.com graphing calculator, or you can make a table. Again, for the homework, that's fine. Just graph it. You're going to have a lot of these. Like I actually have on my notes here, it says repeat a lot. If you just need to get through your homework, just go to Desmos, graph these things. It is not hard. They're all multiple choice. Just graph it, click it, graph it, click it. But what I'm hoping that you're going to be doing at some point is actually studying and understanding how to do it by hand. And here, note something. Note, they're all multiple choice. They're all multiple choice. So I'm not going to do this. I'm going to try to make the table. And I'm going to see at critical points if I can make this graph. At least I can pick the right graph from like a list of options. So when you do r theta graph, what you actually do is choose your theta and get your r. And so I'm going to choose a theta of 0. 0 radians, 0 degrees, whatever you want it. So plug it in right there. Cosine of 0 is a 1, so 2 plus 5 is 7. And you can start graphing this stuff right here. So going in this direction, we got 1, 2, 3, 5, 6, 7. There you go. Let's do pi over 2. So plugging into pi over 2, you get a 0, so just 2. So I'm looking straight up, but I want to go 2 distance. Continuing on, I got a pi. When you plug in a pi, you get a -1, so you got 2 minus 5 is actually equal to -3. So I'm facing this way, but I go back 3 negative. You can see already what kind of shape we're going to have down here, and it connects back. It does this, like this here. There you go. Definitely not the prettiest picture I've ever drawn, but that's the idea. Pick the multiple choice answer. It's this guy right here, and then you're done. So I'm actually done with the 10.3 stuff. Let's do the 10.4 stuff. And again, not much here because it's pretty fast and easy, but I did see a couple strange ones, so I wanted to actually mention those. R is equal to 2 over theta. Theta equals pi. It says find the slope of the tangent line at theta equals pi. That's kind of weird, isn't it? So they say find the slope. Well, they're basically wanting dy dx. And how do I do it with polar format? Well, let me actually give you a formula because, well, that's what we're going to have to do here. Dy dx is actually equal to, here we go, f times cosine of theta plus f prime times sine of theta, all divided by negative f sine of theta plus f prime cosine of theta. All right, awesome. There we go. So when I say f, I actually mean r, and so I'm going to mean this guy. It's a function, and you're just going to be plugging them in. Of course, I don't have my f prime yet, so like r, f, whatever you want to call it, is my original. And then my r prime, f prime, whatever you want to call it, is now a derivative. Remember that this is technically a -1 power, so derivative bring it down to the front, and you -1 from the power. So that's going to be your two functions there. And then I just plug in, right there, theta equals pi. And so what I actually have here is 2 over pi cosine of pi plus -2 over pi squared sine of pi, all divided by negative 2 over pi sine of pi plus -2 over pi squared cosine of pi. Wow. Turn the page. A lot of this actually cancels out. This guy and this guy apparently cancel. Oh, because, well, sine of pi is 0. So those are zeros. They cancel out. This is a negative and a negative. They actually cancel out one another. The 2's should cancel out one another. You still have a negative right there. The pi's should actually cancel one another and come up to the top. Negative pi is your final answer. Cool. All right. 10, 4, 0, 3, 3. And so I've got r is equal to 1 plus cosine theta. And it says find my r theta whenever we have a horizontal or vertical tangents. Okay, awesome. And so what do they mean by that? Well, again, let's go back to my formula right quick, and I'm going to use r's this time if that's okay. R cosine theta plus r prime sine theta. R sine theta, is it a negative? Negative. And then plus r prime cosine theta. Okay, so that's my original formula there, and I can plug this stuff in. Cool, whatever. Here, let's find my r prime while I'm sitting here. So the 1 goes away, my cosine goes to a negative sign. Okay. Nice, nice. So now what? Well, when they say horizontal, and we saw this last time, they're trying to say dy equals 0. That's going to be my top is equal to 0. And so what I need to do is just plug it in and then start solving. And so if you distribute your cosine here, you get cosine theta plus cosine squared theta minus sine squared theta is equal to 0. I remember that this here is its own formula, 1 minus cosine squared. It's another way to write that. So I've got cosine plus cosine squared minus 1 plus cosine squared. I distribute the minus sign to both of these guys. Still equals 0. These guys actually combine to make a 2 cosine squared theta plus cosine of theta minus 1 is equal to 0. What we need to do at this point is factor it. And if you're not really cool with factoring cosines like that, I understand. You could just use like y or x or something like that. So here, just imagine it were something kind of like this here, and I need to factor it. Now, I'm not going to go through all the lengthy ways of doing this. I mean, it's your Calculus 2 now. You can factor something that's a little bit more difficult, I hope. There's some 1s here. If we make that's a positive 1, so I would need that positive and a negative, and there you go. So same idea here. I'm just going to put these guys. You don't really need this. But now I can solve for each one of these, and I got cosine theta is equal to a positive 1/2. And then over here, I've got cosine of theta is equal to negative 1. This one's actually super easy. The only time you got cosine equal to negative 1, your x value equal to a negative 1 is at pi. Okay. On this side, though, you have two answers. Positive 1/2 for my x value is going to be here and here at 60 degrees and at 300 degrees. And so we actually get two different answers at pi over 3 and 5 pi over 3. Okay, so these are your answers. What you need to do is plug them back in to your R to go and get your R values. And again, R theta kind of format, that kind of stuff. I'm not going to do that. It's super easy. Just plug it back in right here. You'll get some other numbers. I didn't actually do it on my notes. I just said, hey, plug it back in. Okay. For the vertical tangents, which we haven't done yet, that means that my dx is equal to 0. So that means that my bottom is equal to 0, which means this formula here is equal to 0. So a negative of that formula, 1 plus cosine theta times my sine theta plus, and then I have a negative sign, that's my derivative, times my cosine is equal to 0. This is actually super similar. I got my negative, I guess. Well, let me just go ahead and distribute this guy and my negative. So I got a negative sine theta. I've got a negative sine cosine. And then I got a negative sine cosine. These guys combine to make negative 2 sine cosine, which, gee golly, I've seen that formula before. It's sine of 2 theta. You memorized some of that stuff, didn't you? This is cool. You can move one over, start solving and stuff, but it actually is harder to solve that way, and I don't recommend it. I know that, oh man, you can always simplify down, but you don't need to simplify here. In fact, what I'm going to do instead is I'm going to factor out the negative sign to the front, leaving behind a 2 cosine theta minus 1. And this is super easy now, so I'm saying sine is equal to 0, and then cosine is equal to a positive 1/2, just like, well, oh, no. There's a, hold on. If I factor out two negatives, right, I actually need a positive right here, so this is going to be, when I move it over, a negative 1/2. Okay, whew. I looked at my notes, and I was like, wow, I messed up. So there are slightly different answers here. Sine equal to 0. My y value is equal to 0 right here and right here, so you got two answers here at 0 and pi. And on this side, I'm saying it's equal to a negative 1/2, so it's going to be here or here. Your two answers on this case is going to be 2 pi over 3 and 4 pi over 3. And so again, you plug them back in, plug into R to get your R theta format that they're looking for in WebAssign. And that is it. That's all I got. We're done. Thank you very much, and have a great day.